Welcome to qnawire.
So in this problem, we have a capacitor, and the charges on the capacitor is fixed in this problem. And we insert some material later, and we found that the electric field before we insert the material is 3.2 times 10 to the fifth watt meter. Let me double check. Yeah, fifth. And after we insert this dielectric, E prime becomes 2.5 times 10 to the fifth watt per meter. Okay. So in part A, we want to find out the charge density on the dielectric. So basically, we know that if excuse me. So for the capacitor, if it is filled with air, we have expression inside the material in between two plates, E equal sigma over epsilon naught. So where sigma is the charge density on the plate. Okay, and you'll see that sigma here equal E times epsilon naught, right? So before we insert the material, we have the charge density sigma equal 2.83, sorry, 2.83 times 10 to the negative 6 coulomb per meter cube per meter squared. But after we insert this material, we have E prime right here, right? So we have sigma prime equal E prime times epsilon naught. So this gives us 2.21 times 10 to the negative 6 coulomb per meter squared. So the charge density on the dielectric is simply the difference between sigma and sigma prime. So delta sigma equal sigma prime minus sigma. So here we choose the absolute value. Okay, we just want to find out the magnitude. So you see that this equal 0.62 times 10 to the negative 6 coulomb per meter squared. Okay. So this is the charge density on the electric. And in part B, we want to figure out the dielectric of this material. Because the charge is fixed on this plate. So before we insert this material, we have the potential difference V equal Q over C, right? And after we insert it, after we insert this material, V prime will be equal to Q over C prime, right? And the V also equal E times D. So for this one, this equal E prime times D. So E here label the electric field between two plates, and the separation is the same for the two capacitors. So we see that hold on. So we see that E has the expression Q divided by C times D, and E prime equal Q divided by C prime times D, right? And for the parallel plate capacitor, we know C is given by kappa epsilon naught A over D. So in that sense, C is proportional to kappa. So by using these two relations, we obtain that E over E primed equals C primed over C, right? Because C prime and C, they're in the denominators. So, and C is proportional to kappa, so this simply equal kappa, okay? So you see that this equal 1.28.